What does it take to close a $1 billion enterprise customer with only a 6-person team? Today I'm joined by Adrian, the founder of Solitude. He just closed his first enterprise customer using a document extraction API, and today he's going to show you exactly how he built it. In this video, we live code a document extraction service using vLLM and Qwen2.5. You're going to see exactly how Solitude built their document API, so I'll just stop there. Let's get right into the video. We're going to go through a live coding session with Adrian, founder of Solitude, and we've been working together for what, like 6 months? When did we first meet?
6-7 months ago, something like that. Yeah.
You know, we didn't talk for a while, like face to face. I just saw you on Slack. You were like a little avatar. But yeah.
We connected 6-7 months ago. The company was in a different, Solitude was in a different stage at that time. So we'd been working on the idea for about a year or so. And then when we came to speak to you, we just started to land some of our big contracts. Just for context, Solitude is a platform to hire and manage AI agents, kind of like the same way you do people. Think of like Fiverr or Upwork for AI agents. Companies can come and hire agents for different roles. Right now, we focus on accounts payable, receivable, and finance, and we're really big and we're getting into logistics. And we also let builders, we'll soon be opening up a builder API. We let them host agents, and we take care of everything from deployment, infrastructure, which is what we'll talk a bit about here today. And we make sure that those agents are GDPR compliant and soon SOC 2 compliant, and that they'll run wherever customers want them to run, so that you can build $1 billion business on our platform, and businesses can just hire agents and sort of scale their business that way too. So we just landed our first enterprise contract yesterday. Super awesome with $1 billion company, and started to get a lot of leads in. So really happy that we chose Beam. It's worked out really well for us.
Dude, that's incredible. How difficult was it to close them?
Man, that is a great question. And we didn't think that we would start in enterprise. We thought that we would start smaller and work our way up from there. But the market kind of pulled us in that direction. And I think a lot of it, to our surprise, was really education. So education was a big piece of closing those things. Everyone wants to use AI, especially more established businesses. They don't always know where to use AI. And so lots of educational content and showing them the way and finding processes in their business, which can really help them, was a big piece of that. So from first conversation to close for this contract took us about 2 to 3 months for what we're shipping for them now. And that account is set to grow to something close to $500,000 a year at full scope. They wanted to start with one agent, which has been working for them, and then scale up to 2 or 3 or 4, and then start rolling that out across 19 other offices worldwide. It was a bit of a tough one, to be honest, but we managed to pull it off with a small team. We're 6-7 people.
Amazing.
Managed to get that through.
I feel like 2 to 3 months isn't even that bad for a big company.
Yeah, it's not that bad. I mean, considering they have about $1 billion in revenue, I didn't think that we'd be able to close it in that time. But it just goes to show the urgency and the importance of picking a problem to work on that's really urgent. We focus in logistics because the shorter sales cycles there. So they have usually 2 to 3 week sales cycles, and that's really our bread and butter. This customer is a bit further up the supply chain. They're actually in commodity trading, but the use case was basically the same. And because they were really just weighed down by lots of manual processes and paper and stuff, they really needed to move off. So they're willing to sort of shortcut all the process and get things rolling.
Amazing.
Yeah.
Super exciting. And yeah, great validation for what you're doing. And let's see the magic. Let's see how this is possible and how we could use this framework to also get enterprise customers.
Yeah, let's do it. I mean, I'll just start sharing screen now. Can you see that right there?
I can, yeah.
Awesome. So today I just wanted to give Beam a big shout out as our main infrastructure provider that's helping us serve these enterprise customers. And with Beam and all the infrastructure you guys provide us, where you can get up to thousands of documents basically processed via visual language models per hour, and that's been a really big hit. And the main thing that Beam lets us do is it really helped with pricing. We're able to offer fair and fairly transparent pricing per customer, because we know, how long it took for a single file to get processed, and we can use that as part of a unit economics and then scale things up and down on demand. So today I'm just going to walk through an example of a document processing workflow using a really popular model, Qwen2.5 VL. We're going to use like the 7 billion parameter version, and we'll show just a little bit of how we use a model like that and similar ones. I recommend fine tunes for anyone who wants to use that to just do document processing workflows. So today it'll be more of a walkthrough of like how to use LLM in a wider workflow. And you can imagine what we'll code here today you might use as a step or as a tool in a broader agent processing workflow. So I'll just get going and we'll start running. So I'm just going to remove this sort of starter code that we got from the Beam Quick Start. And the first thing you want to know is how to serve in terms of serving large language models for production is you're probably going to use vLLM. If you don't know about vLLM, go check it out on GitHub. Amazing project. And anyone who does anything on the frontier of language models usually makes their stuff compatible with vLLM. So I'm just going to quickly I'm going to set up the main Beam service. And what I'll do is I'll just quickly do def inference. That's how to do it. We're going to pass in the context. And we're going to return fast API. Make sure that I have that in my local thing. Yeah, totally have fast API. I like to type on my Python because I've been burned by untyped Python in production in the past. So that's why if you see me throwing types everywhere, yeah, take it from me. You don't want to use untyped Python in production. It's super painful. So we'll set that with a pass for now. And first thing we'll do is actually just set up Beam real quick. So just import ASGI. Make sure I know what I'm looking at. So import ASGI. And in there, we'll actually just give it the name Solitude colon. And what the first thing you want to do, especially if you are downloading models from Hugging Face, is make sure that you've used Beam, I think, add secret or something like that.
Beam secret create, and then the name of your secret.
Create. Yeah, and then here you'll have like name and then value. So use this to add your, Hugging Face tokens and that kind of thing. So I'll continue on with ASGI. I'm almost going to import that from Beam right here on top. Should move that so we don't bug up the thing. So great. And already cursor is doing its thing and started to add a few of these things. So I'm just going to go ahead and accept that. Let's grab image. And right here, I like to give these containers 16 gigabytes of memory just because you're sort of loading things in memory, like models. It's just good to have. I don't typically use more than one CPU, so you can keep that pretty low, optimize your costs. And what I'm going to do here is quickly add a volume, and we'll see why that's important in a second. I'm going to copy this over here.
And in your case, the volume is where you're storing the data set we're going to use or the PDF?
So in our case, the volume is just where we're going to store the model weights. I'm just going to use a URL for the invoice that we're going to use today to just pass it through as an example. And it's important to use volumes because you don't want to download the model every time the Beam container spins up. It's probably a good time for me to just quickly talk about just how the Beam API works. So we're going to use Fast API today to sort of host this endpoint. And the awesome thing about Beam is when you hit the endpoint, it'll spin up the container. And Beam's done a lot of awesome work to like really reduce the close start times and make that really great. So using a cache path ensures that when we download a model from Hugging Face, for example, that Beam doesn't have to, that when the container spins up, doesn't have to download that every time from Hugging Face. It'll just quickly load it from the cache. And in my experience, a 4-bit quantized 7 billion parameter model can load in like a second or less. So that has a great effect on like user experience, for example.
Very cool.
Yeah. So let's just grab that. I'm also going to grab this tokenizer path here. Great. And I'm just going to now add a bunch of packages just so we don't have to like see me add that over time line by line. So take that here and pop this in. So as I mentioned today, we'll be using vLLM. And here are just a few bits that sort of go into making sure that when we deploy it, it all works pretty smoothly. Some of your standard packages like transformers, accelerate if you're using Qwen, HF transfer to make sure you can download anything you need from Hugging Face. I'm just going to add that now to Poetry. Poetry add Hugging Face. I think it's like that. Great. And then bits and bytes. This package we probably won't use today, but it's important if you have a model that's not already quantized, which we recommend to quantize models just to make it faster in production. You can just pass this into vLLM and it'll automatically quantize that to like four bits. So that's one of our packages. I also like to just run these commands on the container just to make sure that we have some up-to-date Linux packages, and a few of these sort of related to inference and serving as well. That's code for, I'm pretty sure these help a lot with our inference. I don't want to mess with something that works. And then just a few bits here that we'll need. So one of the best things about Beam, of course, GPU access, and I have to keep warm seconds, about 10 minutes, timeout 300 seconds. Usually timeout 300 seconds is really good because it means that when your request first hits the service, it can wait long enough for the model to be loaded to memory on cold start. Anything else that I'm missing? I think, and we'll add secrets with the HF token here I mentioned earlier. I've already added my secret, so that should populate as we expect. And then this probably isn't relevant today, but in production, pretty useful, which is this QDepth autoscaler. And this just lets you control the maximum number of containers that you spin up and the task per container. So for us, for really high volume customers, we'll spin up 3, 4, 5, 6, 7, sometimes 10 containers and just have them all processing their own documents, which gives us that throughput and creates a really great user experience for our customers. So that is kind of the main setup that we need to get us rolling here. The one thing I'm missing is on start. So now we can get to like writing some code. So Beam has a really, really great feature called onStart, which lets you pass in this function here. And this function, Beam ensures that, let's say you have 10 requests hit a service. This function will only run once when your service spins up and then never again. So you're not reloading the model into memory every time you get a request. This is actually a really powerful pattern. And I'll show you here how we can use that to set up vLLM, get a bunch of things set up, ready for serving. So first things first, model name. And let's make sure I'm using the right model here. We're going to use this variant of Qwen, kindly provided by Onslaught. So actually, this is instruct. Let's grab the 4-bit quantized version right here. Here we go. So we're gonna grab this 4-bit quantized version, and the reason we like to sort of pull it quantized out of the box if we can is because it just makes it faster to download, and also just actually reduces the amount of memory that we actually store on the volume, which just has a cascading effect of improving load times across the board there. And then we're gonna go ahead and now start to set up vLLM. So first things first, I'm just gonna import async engine args from vLLM. vLLM recently moved to version 10 and serving engine v1, which please add community naming schemes, let's make them less confusing. And we're just going to do a bunch of setup. We already have model name there. We can now start to add a few other bits. We can grab the tokenizer, which is also, in this case, model name. Model name. And then we're going to add enforce eager. And this is just to enforce sort of eager execution there. And then dtype, bfo16. We don't need this. We don't need this. In our case, trust remote code, which typically set to true. This can be the case. I don't think Qwen needs it, but for a lot of models that do some custom processing, they might need to run some custom Python code, so you can set that to true. And then I'm going to do CPU offload gigabytes to 0, just to make sure that everything just gets piled into GPU. I know that for Qwen, the Qwen2.5, the max input tokens or the max context length is 32,000 tokens, which is what we have here. And I tend to like to set an overhead for GPU memory utilization to just to around 0.5. Sometimes if it's a bit higher, it can throw things off, and it's just good to have a threshold amount. Anything over that amount will probably just scale into another worker. And specifically for Qwen, because today we're going to be passing images, we're just going to limit the context or multimodal tokens per prompt to maximum of seven images. I've tested a whole bunch of configurations. This is the one that works. So take it from me. Save yourself hours of debugging how to get Qwen running reliably. And we're going to grab. We're also going to enable prefix caching here and chunked prefill. Pop that in. And these are just vLLM optimizations that let it sort of chunk together tokens in the KV cache, and also actually cache things, which is a lot of vLLMs like secret sauce to ensure that like it can make the inference process as fast as possible. Anything else? Oh, and of course, download Deer is our cache path. And I think if I just check everything here, that's about everything. We need quantization, tokenizer, and forest eager. And something that so this is really important now. We're going to add guided decoding. So this is really important because vLLM recently introduced support for decoding backends. So this is related to an idea called structure generation. And what this means is there's now lots of great open source projects. I happen to like Outlines TXT. And these are projects that will hook into the token decoding process. And it will actually restrict the possible samples that the LLM can output. In our case, the reason we really like Outlines is because it works great with JSON schemas. So this lets us build around LLMs the same way we do regular software. What you'll see in a moment is that I'm able to pass in a JSON schema into my service and do inference, and I'm guaranteed to get a JSON structure out of the LLM. So this is really important for production scenarios because it means that I don't have to beg the LLM to please output JSON pretty please in my system prompt, and that saves you lots of time. So let me just check everything here. So I'm just gonna pop in these ones. We can then go ahead and start to load in the LLM configuration. I imported this here. So basic engine args, basic LLM engine, lovely. Here and here. If you import that instead from here, and then we also want our processor from the transformers. I'm also grabbing these types for pre-trained tokenizer base and Qwen2.5 VO processor, and that'll be important when we stitch together the onStart method with our main method there. So I think we're all good to go, almost. Last thing to do is set up a tokenizer. And I am just going to actually also add a type declaration on the top of this onStart function. Should be okay. Copass name, and then there. Lovely juggling. All right, so that's our onStart function set up. Anything else you want to say about this, Eli, or we get to move on to the main meat now?
Yeah, maybe just real quick, like, is vLLM the best serving framework to use for your use case? Are there others you looked at?
Yeah, so we looked at a few. So I think a lot of people start out with transformers, and transformers is really good until you start to like try and productionize it, and then you realize it's pretty slow. And then if you do a lot of research, you'll find like a lot of teams end up sort of going down the vLLM route. And there's some other serving frameworks you might think of, like Ray or something like that. And then if I remember, the other ones don't come to me off the top of my head, but I think that the industry standard now is really much converging on vLLM. There is a bit of a learning curve to make sure you understand all the different configuration parameters. They've tried to remove a lot of that with quote unquote V1, with the V1 engine, so it's pretty performant out the box. But most importantly, I think every open source model will ensure that they'll release a patch that makes it compatible with vLLM. So usually if it works with transformers, it works with vLLM. And unless you want to do something very crazy low level and maybe even roll out your own CUDA kernels, vLLM tends to be the way to go. And they've even implemented lots of mechanisms like flash attention 1, 2, and 3, as well as there's another one they recently rolled out. where they've also put out some like research grade CUDA kernels that have massively improved inference time as well. So I think like if you want community support and documentation and a pretty good chance that your model supported, if it's plug and face on a recess on a fast serving framework without rolling out your own, vLLM is probably the way to go there.
Industry standard.
I'll say so. Yeah, I think if you're serving models in production, it's very likely using vLLM in some way. So I guess we can move on to the fast API side of things. So what we'll do here today is I'm just going to write up one single function, which is going to be our main sort of like inference function there. I'll actually call this generate. And what we'll do is the plan rather is do this. Cool. The plan here is to write up a HTTP endpoint that lets us, that takes a file URL, some sort of system prompt or user prompt, it takes a file URL, a system prompt, some sampling parameters, and a JSON schema, and then reads the PDF from that URL, and then passes that through the vLLM, and then extracts out key information from that PDF into a JSON schema of choice. So that's what we're going to go ahead and implement here. And the good thing about using JSON schemas is that we can add all kinds of like type safety around that, which is really good when working with like a larger team of engineers. So let's go ahead and quickly paste these things in because no one wants to see me type these out by hand really. Let's just do a bit of poetry, JSON. Oh, I got those press, but PDF. I think I've already added a bunch of these, so we're good.
And by the way, if you want to avoid having to import these like locally, they're already in the function.
Yeah, sorry. That's a real feature. Please talk about it. Yeah.
No. I was just making sure that if the packages aren't local, you could have them nested in the function or use that if env is remote method, and that way your interpreter won't try and import them locally if they're expected to run on Beam.
And this is particularly the case with really finicky packages like flash attention. So if you don't have a local GPU, you actually can't build flash attention, which is really necessary by some models like DOTS OCR. So that's a good chance to adhere to import that if you want to use it. And then for any particularly nasty, quote unquote nasty packages that can be a bit difficult to install locally, like for instance, there's an OCR package called Tesseract, which you might be using to scan PDFs for text for preprocessing. Then a really good pattern is just to sort of do an apt-get install like Tesseract here, and then for instance Tesseract OCR, and then Beam can go away and do that. And then, of course, if you actually need to build something with a GPU, then there's an argument you can pass in here, Eli, if you can remind me that ensures it's built with a GPU.
Yeah, so actually it's on the image. You could do with GPU, build with GPU, and then you can pass in.
Yeah, so if you're building anything that, for instance, flash attention comes to mind immediately, that requires GPU to build, builds with GPU, there you go. Then this is an amazing feature. Saves you a lot of hassle. So we won't need that today, so I'll just remove it. And let's just get into the meat of the function, man. So I'm just going to quickly show off my poetry automl file just so people can see what dependencies I'm working with. A lot of standard ones. PyMove PDF is one of the best libraries for reading PDFs. If you're doing document parsing, guess what? You're probably using this. You're probably also using OpenCV Python if you're working with images. And what you'll see us do is we'll convert PDF pages into an image and then pass that into the model. And pro tip, visual language models work really well, obviously, with images. So if you have a table and you want to sort of do inference on like a table, a really good way of doing that is actually taking that Excel file or CSV or PDF, converting that into an image and then passing that into a vision language model. You can get some really magical results out of there. aka extract the full table into a JSON schema, which is great. So yeah, these are our dependencies. Specifically for today, we're using Qwen utils. And this is important because Qwen has a micro package for making sure that images are pre-processed in a way that the LLM can infer. So last thing here, we do app equals fast API right there. Give this a pass, and then we return app. We are ready to start going. Let's get into it. Let's add, have I imported the app here from Fast API? Make sure we have that going. I think I already do. Making sure. Yep, I have Fast API, cool. So we're good. Let's just grab, I'm gonna make this a post endpoint and do post/generate. And Fast API works with Pydantic. So what I'll do is I'll actually just define make sure I have Pydantic in my environment here. Poetry Pydantic. And I'm just going to import from Pydantic import base model. And the first thing I'm going to do is just quickly set up what I expect my inputs and outputs to be for our generate request. So we'll call this request base model. Copy some things over here. There. Make sure they all inherit base model. So, and then I'm going to break this down in a second. So let's say document params and parameters. So what we're going to send into our request is two things. We're going to send our document parameters. And what I'll do today, I'll remove this and I'm going to keep these things. This is optional, so I'll remove this for now, just remove some clutter. And so we're going to pass some document parameters, which includes our prompts, JSON schema, and the URL of our file. And the reason I use a URL here is because in production, you're probably working with buckets or saving files remotely that users have uploaded. So what you want to be able to do is make sure that you can pull that from a URL and download it into your process. And then sampling parameters. So the reason I like to pass these in via request is because it makes it, first of all, easy to test different sampling parameters and see what works for you. So actually for PDF processing, we want something closer to 0. And let's say open a 1 for top P. And so temperature increases randomness in the LLM's output request. So we weight that 0 or something close to 0. Maybe we do like open a 1, for example. And this is because we want to just choose next probable tokens. So only select things that are actually on the document because it's still prone to hallucinations, and there are some strategies around that. And then top P is a reference to the total tokens it can sample. So a really high top P lets it consider a very large distribution and a very wide net of tokens to sample. A really small top P restricts that to only the most likely tokens. Make sure I have like Google search top P. Yeah. So I am correct. Sanity check there. So yeah, a low top P just restricts the total number of samples that the LLM looks at before deciding to output a token. So because we are reading from a PDF and from a file where the ground truth is already there, we don't want it to be creative in any capacity. So we make sure that these samples are pretty low by default. So we pass these in for a number of reasons. First of all, it makes it easy to test. You can test out different values for a use case, which is really cool. Then on the other side of things, by passing in sampling parameters as part of the external request, it means you can use different strategies when it comes to sort of trying to make the model more accurate. What I mean by that, there's a great startup called Hebia, who works in financial software. You probably know about them. And they pioneered, they say they pioneered test time scaling. And so what that kind of means is instead of sending one request to an LLM, they will actually send 100 or 1,000 requests, sometimes with different models, but also with lots of different temperatures. And then for a given output, they'll have an LLM as a judge pattern or another kind of mechanism vote on on the answer that occurred most frequently. So having this set up like this sort of lets you implement those kind of patterns really easily just via HTTP request without writing complicated, Python or orchestration around that. And there's a variation of this, which gets even more fancy, where you can use the Beam QDepth autoscaler to orchestrate all that so that you can sort of have a lot of these models vote in parallel rather than just doing it one at a time. So let's just get into the meat of it then. Back here. So I'm gonna just pop in a bunch of, we're gonna actually just grab this and grab the inference data. So we're gonna reference inference data. We're gonna reference that. And we're gonna also just grab the actual Fast API request object, just so we have access to it. And we're gonna return, surprise, surprise, a response. And let's do this response there. You have to import that at the top level, or is it still on me? So that's all set up, and we'll just get into it now. So I'm gonna pull the prompt from our request and do some schema. We'll just grab all these, the cursor. Is this page limits? Oh wait, we got that today. Cool. We'll just grab all those things just straight out of the request. So we're gonna grab the prompt, using schema, and the download URL, and we have to generate a random UID for vLLM. Let me just make sure I imported that as well. Just add this here. Actually, pop that over at the top. Just good types. So we're generate a random UID, and this is so that LLM, because vLLM can batch together requests, and it can do greedy decoding or chunk prefill. And what that means is if it gets 4 or 5 requests in parallel, you can take them all in and then stream out, if you need it, the tokens as they're available. So that lets you sort of scale up your service and immediately start handling multiple requests. Not so important today, but just important to pass into VLM. And we will just do a bit of setup here. And the first thing we'll do is actually just grab our messages. And every sort of LLM family has their own way of accepting prompts, interpreting prompts, and sort of prompt templates. This is how Qwen likes to have their prompts. They have a role system, and you'll see another role soon called user. And so we're just going to prepare this and take the prompt that we got from our request, from our generate request, and use that as our system prompt. Depending on your model, you might actually want to just hard code your system prompt somewhere else in your system and not let the user actually send that in. So let's grab the download, and then this line here, download URL. This line here will download our file into memory, and I'm going to import document from PyMove PDF, and PyMove PDF, and it's pretty important. So what we'll do today is, rather than download the document and just actually download it to disk, which can really slow down the request for the user because of the transfer to disk, we're going to be doing all this in memory, so it's like nice and fast and snappy. And I also have some cleanup functions for PDFs that I've handwritten for everyone's behalf, and we'll pop that into a separate file. So it turns out PDFs are in fact kind of annoying to work with sometimes. So we wrote a bunch of just cleanup functions, just clean up PDFs, make sure that all the bytes are in the right place and any sort of templating items are present if need be. So I'm just going to actually just call those. This isn't super important. Your average PDF will work. But in production, we've seen some very nasty PDFs. Like people take pictures, or they'll create a PDF on their phone, and the app for some reason hasn't correctly formatted the PDF data format. And so this is just a catch-all for that. So I'm just going to import that here from PDF utils and paint page index. We don't need this one today. We're just going to quickly clean up our PDF as well, just in case. Happy to answer questions and comments about how to clean up PDFs. I know way more about that than I ever wanted to.
Do all industries have the same PDFs, or have you found that certain industries have like a consistently different format?
What do you mean by that exactly? There's a few different answers depending on where you're looking for.
Yeah. So like finance companies, financial services companies versus logistics companies. Do you find that depending on the industry, you might get PDFs in like a specific format where...
Yeah, so that's definitely the case. So in our experience, so in logistics, because a lot of logistics relies on carriers, aka truckers or shippers or like port authorities, a lot of what happens there is you have people. There's this document called a bill of lading, and it's a confirmation that this that a good that has been ordered has been shipped to the right place, and it's basically a document that says, hey, this is what I've shipped, this is the weight, and it's signed by the appropriate authority. So because a lot of this happens on the road, like truckers will sort of stop in somewhere and just drop off the item. They'll take pictures on their phone and then combine those pictures into a PDF, which might contain other important documents like a rate confirmation or an invoice. And so in that kind of PDF, you'll have a mix of like something created in like a digital product, let's say. So they created in like PDF software that's very clean, very easily readable, and then combined with pages that are just a picture. And then because it's taken on a phone, sometimes on an Android, that picture sometimes has weird encoding on that picture. And so that PDF is like a scramble of like both regular PDF content plus pictures. And sometimes the app that they use to create that is a bit broken, so you have some embedding issues. Whereas in finance, for example, you deal a lot more with very well structured PDFs. So more often than not, you can actually just pull out data from the PDF. It's like a rich PDF, let's say, and this PDF encodes all the data within it. So there's like a clear table structure encoded within the PDF bytes. There's clear text. You don't have to actually use OCR. You can just pull the text directly from the PDF. Sometimes the PDFs aren't interactable. We haven't come across those yet, but they can be interactable. So yeah, from industry to industry, everyone has their own flavor of PDFs. It can get pretty hairy once you start serving lots of different ones. So you end up having to write lots of cleanup code just to make sure that that you can service all of them reliably.
Fascinating.
I know way more about PDFs than I should. I never thought I'd get this deep into PDFs. Like please take it from me. Yeah, and so that's sort of where these cleanup functions come from. I don't think we need it today, but just to make sure our demonstration goes smoothly, just pop them in there, which is why I've gone to them. So now we're going to get into the really important piece. So the first thing I'm going to do is create this list, which is going to contain all of our user role messages. So earlier I mentioned the system role. We're now going to pass in all these messages as the user role. All these pages of the PDF as a user role. So what we'll do is we've already opened up the data, and we're just going to come in here and type for I, and let's do page in enumerate data. Today we only have like one page in the sample data. We are going to do a bit of magic. So it took me a while to sort of combine the right docs to make sure everything happens in memory. We don't want to save things to disk. So hopefully I save someone else some time here. We'll do pix equals page.get pixmap, and we're going to pass in the matrix. And this is the PyMu PDF matrix. And we're going to do this. We're going to call this 1-1. So what's happening here is we are grabbing the pixel map of this page, so just the straight pixels, and we're passing in a matrix. And what you might do in some scenarios is actually make this 2 by 2. This is actually a scaling matrix. So if you pass in higher or smaller numbers, you actually scale the page. Sometimes this is really useful. Let's say in finance, where you have a really rich text a document where it's all vectors, so it's not rasterized images. It's sometimes useful to scale it up, and the vLLM can then catch small details that you might have otherwise missed. So iterable. I happen to know that data is iterable, so I'm just gonna ignore this alert type warning there. But what I'll do is I'll just quickly one just in case. Hey, can I add in a type ignore? Can I be cheeky? Oh no, we're good. Nice. All right. Great. So we have get pixmap, and PyMu PDF doesn't have types, so I will add a cheeky type ignore right there. And we will. I'm gonna make this 1-1, and then we're gonna grab the bytes real quick right here. So this will give us the bytes as a PNG, and we'll see why I'm doing all this weird setup in a minute. And then we want to, turns out, base 64 encode these bytes to pass them into Qwen. So I'm just going to quickly import at the top here, 54. That's great. And then we're going to now actually add our content. We add a content append. I'm just going to pop in this thing right here, this array. What have we done? What have we just done? We're iterating over the pages in the PDF. We're grabbing the pixel map in memory. We are converting these to PNG bytes, so for the .png format. This is specific to Qwen. I know Qwen looks for PNG encoded pictures. We then base 64 encode these bytes, and then we're going to add a entry to this array here for every page. In this case, I know we'll have one page, where we mention the type of data encoded within this prompt, which is an image. We then pass in the image. And so Qwen2.5 VL expects this particular format to be passed in as an image. You can also pass in image URLs. We do it this way because in our system, we sort of upload things to buckets, then download them. So it's the best way for us to do that. And I like to have control over the image. And doing it this way also lets you do additional transformations on the page before passing it in. So a neat trick is you can actually paint page indexes onto the PDF. So here's something that we bumped into that you wouldn't realize otherwise, which is, let's say you have a PDF that's 7 pages long, and 3 of the pages might be pictures of a page on another document. So the picture might contain text that says page number, even though logically that page is number 6, or it might say page number 3, but logically within your PDF file that you're processing, that's actually page number 7 in your actual logical file. So that can really throw off the vLLM. So a really neat trick is to actually just paint page index or something like a red box on the top of your PDF, and then you can refer to that in your system prompt. And you might do that transformation up here if you wanted to extract out the correct page numbers. So yeah, keep that in mind. And
That's very
then
interesting.
yeah, it's also really annoying.
That's like a great pro tip.
Yeah, it's a nice little hack. Like we tried a bunch of different things, and that small thing kind of shot up our accuracy on that, which kind of brings you back to like old school machine learning, where instead of just throwing humongous neural nets at it, you're sort of taught in class to just start with a naive classifier or a tree-based model, and you just start really simple, and then you add the more complex things. Like some people might immediately reach for test time scaling or some other crazy things, but just small pre-processing tips can really help you along. And then just before we move on, there's other kinds of tips, like you might segment the document first using doc layout YOLO or some other sort of like document segmenter, and then extract those pictures by looking for keywords in each segment, and then only feed that into the LLM. Then you save context size, and then it lets you hack the attention mechanism to make sure it focuses on just the part of the document that you care about, for example. We won't do that today because it's a bit more complex, but that's really cool things to apply. And then the last 2 parameters we pass in are min pixels and max pixels. So really, honestly, we only care about max pixels, but Qwen2.5 VL lets you sort of specify max pixels, and it will try to shrink the aspect ratio. It'll try to shrink the PDF or this page into the context window without messing up your aspect ratio too much. Because if it's too skewed, or if it's too weird and wonky or too stretched, then that can really mess up your results and produce hallucinations. So they also have like a max width, max height. I recommend using max pixels because they'll just handle the aspect ratio stuff for you. And then if you're using bounding boxes, I recommend going to the Qwen2.5 VL GitHub to see how they can extract out bounding boxes, and they have tools to do that. And then finally, we'll just quickly pop in messages append after our for loop right there, and we'll just append all this content. So we've now set up our prompts, and we're ready to start passing things into vLLM. So what we'll do is we will make sure, yep, we're going to pull in some things from the Qwen2.5 VL utils package there. So let's grab this, paste them in. And this process vision info comes straight from Qwen2.5 VL's utils, which is Qwen VL utils, sorry, which is this thing here, which you need to use if you work with Qwen. But also, notably, a lot of really important fine tunes like nanonets, OCR, raw ROLM OCR, and really great fine tunes. There's also one called what's it called that we use? Called Tiger Lab VL Rethinker, which is a great thinking variant of Qwen. They all use Qwen under the hood. They're all Qwen fine tunes, and they all use the same thing. So we basically use these functions to just process our models. I'm not gonna lie, these are kind of magical parameters that they just suggest in their repo. Wouldn't be able to explain exactly what goes on, and I'm pretty sure return video key args. We actually tested this out. It's just it'll return a few additional keyword arguments for videos because Qwen2.5 VL also works with videos. And add vision ID. This is really important if you add 3, 4, 5, 6 different images into your model in one prompt. So if you ever want to do cross image matching, you can actually you can actually just add them all in here in a similar way, up to 7, because we define a max limit of 7 up here. And then Qwen2.5 VL and similar models can like compare images and look at, is there a dog in both images, for example? And this can be important for like, for instance, cross document matching, which is important in logistics and also finance as well. And then I'm just going to paste in some more bits. So we're going to now just set up our dictionaries to correctly pass in things into. I'm going to import text prompt. We're going to add that here. Beyond inputs, right? I'm going to pop this right here. My type nerd. Yeah, we're going to pass in. We're going to get things ready to pass into vLLM, and then now we can finally actually do some inference. So this essentially, so vLLM accepts images. We have to pass it in this format, and give these engine inputs. Pass in our formatted prompt, which we got from here after applying the chat template, and then the multimodal data, which we get here from our image inputs. Just to make that a bit clearer, what I'll do is I'll just pop that like that, so you can see how I use them. Yeah, so we then pass in our multimodal data there. And we obviously have our sampling parameters. I'm gonna grab those from here and initialize them. So I'm also gonna pull sampling params repository. In reality, I don't think people actually need to use all the types I'm using here. I think it helps for everyone to follow along, like where I'm importing different things from, and we can look at like some type definitions as well, because everyone loves looking at type definitions. So we actually only guided decoding parameters. That's fine. And you'll notice I haven't imported outlines anywhere, but I have added it to, where are we here? I have added it to our Python packages in Beam. You don't actually need it locally, but this does have to be imported for vLLM to pick it up. So great, that's all there. Oh, we do need guided decoding parameters, I think. I misspoke. Let's grab that. Guided decoding params. Double check that. Guided right here, apparently. So we'll grab that. But yeah, so then we do need guided decoding parameters, and this is for the magic part where we can actually bring in our JSON schema. So, and then we'll put in our max tokens. Let's see if Cursor just picks that up. Nice. Let's go, dude. Nice. So here's the magic. And I can't stop talking about this, which is structured generation is how you build production-ready LLM systems. And vLLM makes it really easy. Pass in guided decoding parameters and make sure, of course, all the way up here, you add in a guided decoding backend, argument outlines. It supports more of the JSON schema spec than other sort of backends. And you can pass in your JSON schema, which we'll pass in a second. And then some sampling parameters, and you pass in sampling parameters. And this will guarantee
So this is the exact code you use to close huge enterprise clients.
Pretty much, really similar. Like we add some initial bits on top for operational security. So I mentioned the try catch block, error catching. We also add tracing and observability. So you can actually add tracing to make sure that all this links into our actual infrastructure and is integrated into OpenTelemetry. But this is pretty much it. Yeah. And then a bit of magic in the system prompt. And yeah, that's what we use to close really big enterprise clients.
Incredible. Okay,
Yeah.
so anyone watching could just copy this and they're not going to have the same magic or riz that you have. But this is a pretty impressive starting point.
Yeah, I think this is great to kick off from. So a really good model that you can use if the default Qwen2.5 doesn't work for you is another one called a fine tune. I'll just show it here on screen, and then we'll work the other one. Is a fine tune called Tiger Tiger Lab, and this one is trained to sort of visually think about documents. So if you have really hairy documents, this is a great fine tune. But yeah, this code just does the job, man. Just a lot of our infrastructure is like wrappers around this to make sure it's sort of scalable and adds table stakes things like team management, SSO, and these kind of things. But at a really high level, yeah.
Very cool. And then how do we deploy this? Like that, this clearly will do the job. I mean, I know you have a document URL too, so maybe that part is good to look at.
Yeah, I'll just go ahead and deploy that right now. We just hit Beam. I've already hit deploy there. We'll give it a name, Beam Solitude colon main.py, and we'll just point it to inference right there. I think I've called this thing inference, yeah. And then if we just hit that, then Beam sort of does its thing. I don't have to touch a Docker container. I don't have to configure any infrastructure. And Beam just builds the image and pops it right up there on the infrastructure. And that's it. It'll build all the dependencies and everything I need and handle auto scaling, which you can tweak with a QDepth auto scaler. And this helps us ship new things to customers every day. We come in here, like our typical workflow is each engineer sort of has their own token. They'll have to do a few experiments, which saves us money from having our own GPUs. Try a bunch of things, Beam deploy, and then it automatically increments the version. And then when we're happy, we just sort of take that, pop that into our main repo, and sync it to our production environment via CI/CD.
And maybe explain the QDepth autoscaler real quick. Just if we look at the way you've set that up, what's going on there?
Great. Yeah. So QDepth autoscaler, it's what it sounds like, which is great. Congratulations on being one of the only people to name something that makes sense. It will automatically scale your Beam deployment based on your requests. And so typically what a lot of teams will do and what I've done, so a bit of background about me, I've set up really large scale machine learning pipelines, data infrastructure pipelines, and data mesh infrastructure for large telecom companies. Like I was previously part of a $2.6 billion portfolio company, and I was sort of the head machine learning data infrastructure engineer there. And a lot of what you do there is queues. You'll set up a Kafka queue, which if you've ever had the pleasure of setting up, sucks. Don't set up your own Kafka queue if you can avoid it. And you'll set up queues as a way, or Kubernetes, even worse. Good luck with that. You'll set up those things to auto scale your services. And this is important because we've all heard of GPU costs. If you have lots of GPUs running all the time, and that really builds up your costs, and then you end up passing those on to customers. So here in the QDepth autoscaler, this lets us auto scale the deployment pretty straightforwardly. No crazy Kubernetes config, no Docker, nothing. And what this is saying here is, let me just click that way, is at minimum, we want a minimum of 0 containers. So if no one's using it, have no containers. Beam, please don't charge me. And then if we get lots of requests, scale to a maximum of 11. And then here in tasks per container, each container should only handle 1 request at a time. You might increase that, and there's additional vLLM config, which I've put away for now, that lets vLLM handle 3, 4, 5 requests without being overloaded at a time. But this lets you have really great control over how your infrastructure scales as you receive requests from customers. And by the time I finish the explanation, we've actually deployed the application.
Very cool. And so now actually when we call this API, because of the way we've set up the QDepth autoscaler, if we send 3 requests, for example, we're going to get 3 H100s running. Is that right?
That's correct. Yeah, that's correct. Yeah. We get 3 different H100s all the way up to the maximum. So I'm going to go ahead and call this API, if you don't mind. And we're going to, I've got a script here on the right that I prepared previously. And I'm just going to remove some things I don't need from it. And we have this there, this, that's all fine. So I'm going to quickly just go grab the URL of our example document. I'll probably show that on screen in a second too. Grab this. And let me see if I can pull it up. You'll be super surprised how many gigabytes of RAM Adobe Acrobat takes up. I just saw earlier today, it was like 2 gigabytes. It was just running casually. So let's just do this. I'm just going to share a screen so you guys can see what document I'm going to pass in. So I'm going to pass in this PDF. Pretty gnarly, low res. And what I'll actually do is when we switch back, I'll switch the model to a different one and just redeploy that. Then we can see how fast Beam redeploys things anyway. So this PDF contains some important pieces. So we have a build to thing here. We have an address here. So we have the billable address and the actual address of the person, I guess, who's issuing the PDF. We have a due date. We have a PO number. PO numbers are really important to pick up accurately because typically, as far as user experience is concerned, you can pick up the PO number accurately. Then you can usually connect that to something in their CRM or ERP. And from there, load up anything that can be used to match against this PDF. And we have an emo here, some quantities, a subtotal, and importantly, to here is that you have a subtotal, and then you have an actual total after the discount is applied. So be aware of that as we begin to do the request. So I'm going to switch over to a fine tune. There, can you see that?
Yes.
Okay. Yeah, I've already hit redeploy. I'll do that again just in case. I'll add a quick comment. This is my new model, and do that again. And because we aren't changing dependencies, we can redeploy a new version super duper quick. So if you use something from the same model family and you use this setup, upgrading the accuracy of your infrastructure and your model is as simple as a one-line change and a beam deploy, and you're done in 5 seconds. That's why people are betting on, and that's why it's important to bet on LLMs and AI getting more accurate in the future, because if you can build a really robust company business model around that and things get more accurate, you're a one-line change away from sometimes a 10, from usually anywhere from a 5 to 10% bump in accuracy as new models come along.
And like so easy too. It's just one line.
Right there. So right here, I'm gonna paste. I have a script on the side, and I'll show a small sample of it in a second. Quickly grab the URL of my file, the URL, and I'm gonna paste it into my script here on the side, which I'm hiding because it contains my token. You have to take my my word for it. But what I'll do is we can see when I hit it, we can see beam spin up. I think, well, look, the token's already there, to be fair. We can see beam spin up a container. Let me see if I can just show the script. Yeah, why not? This will be fun. Yeah, no, cool. So we've already got the bare thing there. I'll actually just open up a new Python file. So touch pull up py, or there we go, post up py. Pop this in there. I'm gonna grab this authorization bearer. Don't worry, I'm gonna promptly delete this key after we're done here. And v3. So here we are. We don't really need this schema right here. So this is our JSON schema. So in our case, we grab the supplier name, give it a max length, and then we won't need bbox 2D. If you want bounding boxes, Qwen supports that. We're going to be reaching support for that soon. And then let's grab all this. We don't need bbox 2D again. Do all that. And you'll see I've done a lot of like max items, min items for a lot of these things. And that's because, again, it's a neat trick to prevent LLM from inadvertently looping and guaranteeing you some JSON. Let's grab that, leave this right there, and we'll do this. I'll leave, for now, just to not complicated, I'll leave these in, and just in case I accidentally mess up the JSON schema. But yeah, so you can see here, what's important is supplier name and a max length on this string. Really important small trick there. Same thing here. And then if you work with a particular customer, you can actually use regex patterns, and you can ensure the LLM follows like regex, like a regex pattern for a string. You can pass in enums. You can pass in numbers and put a maximum minimum on those numbers. You can do max lengths. And then we try to detect build leading pages. You can just delete that there. We'll need this. We don't need this either. And that's pretty much it for the JSON schema. Delete that. And then we'll also delete rate confirmation pages. No, we're good. So we'll leave invoice pages in. I actually don't need that either, to be honest, in this example today. And delete that. Great. So this is what JSON schema looks like. And the beauty of structured generation is that we can just pass this in and it'll just work. And then up here, and then we sort of have the payload. And here I've got a pretty bog standard system instruction. And I make a note about the page index trick here. Don't really need that. So I'll just delete that right there. So avoid confusing the LLM. And build to PO number, and that's all there. We can also delete this. And so what I like to do, just to give the LLM some more hints, is actually just add the JSON schema directly in the system prompt. Here are our sampling parameters, and then just some code to quickly sort of make that request. So if I do Python 3 post, if I do poetry run, poetry run 3 post.py, then that has now gone and started hitting Beam. Oh wait, I should just actually save that. I haven't already saved that.
And it would be
That.
cool also, if you're comfortable sharing your dashboard,
Yeah,
that
no
might be
problem.
cool.
Jump into the dashboard. I'll open it up real quick. Yeah, so here's our dashboard.
And
So
you
this
might
is
have
like,
to
yeah.
share
So this is like our demo environment. So it'll look a little empty. So this is a dashboard. We just run a bunch of experiments here. You can see us trying a bunch of different things, like with dots OCR, trying to work with videos, trying to work with nanonets, trying to do that sort of test time scaling thing here. And you can see here on the left is the Beam item we just deployed. So let's see what's going on. Kind of unpack implementable none type thing. So the issue here, it looks like that stuff. Make sure that works. Oh yeah, this one's sort of error. Gonna need that pie. I'm just gonna my main screen again. Now comes the debugging part of the session. Let's grab and tokenizer. Cool. And then just make sure. Let's try and hit that again. We have to hit that with Beam deploy. There's also how fast it is to debug something with Beam, to be honest. So good showcase. Run. Then we share this window again on Beam. I just shared on my screen, to be honest. So if we here, then I can just hit refresh on this. Go to version 4. See how that did. Hit back. Oh, non-type. I see what's going on. Let's make sure we got the stuff here. Oh, on start. And in this example, it should be context. That's our value. Do I got context here?
Yeah, maybe if you do model data instead of having the variable, just model data. Just compress that into like one line.
Oh, like right here. Oh, like that. Yeah, let's do that. Yeah, let's hope that gets passed in the context the way we expect. We should do. Engine tokenizer processor. This is also engine processor tokenizer. We should be good. Have I passed in on start? Oh, that's why everything worked, because I didn't pass in on start. Lovely. I'm gonna do what I did earlier just in case, but we should be good to go. I'm also grabbing the right order things. Read that type. All right, we should be good. Read that. We hit another Beam deploy. Copy this side there. Start value. Oh, right, my bad. Great. And just increment this script to v5. Poetry. And then back to Beam. Refresh that. Number 5. And we're good to go. So now we've actually initialized our on start value. So what we're seeing now in the demo, I'll just switch to just sharing just this screen because we're past the debugging phase, which I'm sure everyone's happy about. Here we go. So now it's going to do a bunch of boring stuff. It's already downloaded, as you can see, the fine tune that we're working with, Tiger Lab VL Rethinker. And it's just going to start loading that into memory. So downloaded that pretty fast. So really good bandwidth on Beam. And so what should happen is it should set up the language model with vLLM. That should run pretty smoothly. And then it will send through the request, download the PDF, go through the process we mentioned, and then return back a JSON schema.
Very nice. And that PDF you showed before, that was like a pretty ugly PDF. No offense to whoever made that PDF, but there's a lot of stuff going on there. I feel like the format was not necessarily consistent with like other PDFs. You don't know what's going to have an underscore or not. So you probably get that all the time, right?
We do. I think I have a redacted PDF here. Let me see if I can find it. In the back. Yeah, I do. I have a redacted PDF here that I can show, which looks more realistic as to what you can sort of expect in the wild. Let me see here. Yeah, we're good. We can show this one. This one's so this is like still on the bet. So the first one we saw was on the better side of things. This one that I'm about to show is you're more likely to find something like this in the wild. So I've redacted a bunch of information. So this first page starts out pretty tame. Then this page is also pretty tame, but then you get pictures like this.
Brutal.
So, and as you can see, this is page 3, but on the top right, it says page 1 of 1. So that can really confuse the LLM. So that's where the trick comes in. So paint a box programmatically in the top left with the page index and use that. And so we're expected to be able to like read these kind of PDFs, know this is a bill of lading, report which page that is, read this information, check the signature, all in like 11 seconds. And Beam helps us do that. And also the model and system prompt also really help with that too.
That PDF is such a great case study for what you guys
Yeah.
do. That
Yeah,
should be your website, just a photo of that PDF.
We can handle this.
Yeah.
That's how my co-founder's smiling in the background because he's also been sweating over PDFs like these. I've seen some gnarly ones, like even worse. You'll get pictures where the sunlight, with the sun rays, a ray of sun is covering the important information. What's up for that one? This is hop back over to this one to see how Beam's doing. Oh, it's done. So let me check to see if we got response. So this says work. Let's see. Make sure I got my thing out here. Response, detail missing, body parameters. So that worked, but my PDF, my JSON schema was wrong. Just gonna share window again. So let's just see if we can debug what happened there. Document parameters on URL. Oh yeah, it's missing a particular thing. So this is called, what have I called it in here? Document parameters and sampling parameters. What have I called it in main.py? I've called that parameters. That should be correct. Input, download URL. Yeah, fast API can be really sensitive with these kind of things. So prompt, JSON schema, like sample parameters. Let's see what's going to be there. Temperature, max tokens, temperature, top heat. We should be good there. And then download URL, JSON schema, prompt should be there. So we then have document parameters, download URL, JSON schema. Let us ask what's missing. Thank God for Cursor, because I still come from a time where you just crawl through code for months and hit Stack Overflow only to be told you were a noob and you should just get good. See how it does. But yeah, so that's overall the process. And what you see me do now is just sort of the debugging process with Beam, but Beam sort of already did its job. So hopefully by the end of this, we can send parameters, some typo. Oh, API parameters. No, let's just fix. Let's just say fix it.
Easy, seemingly.
Dude, yeah. Used to hire interns for this.
Interns to find your typos.
Intern. There's a really awesome phrase, which is the most junior of tasks done by senior engineers, because it used to be that setting up linters and that kind of thing, which is just good health for your repo. If it was done by an intern or junior engineer back in the day, 9 times out of 10 it'll just be misconfigured and just cause annoyances. Oh, there we go. Summary parameters. Is that even misspelled?
Yeah.
Oh, me with an E. I used an A here instead of an E. That's funny. All right, cool. We'll just hit that correctly then.
We've all been there.
Yeah, classic. Stop GPT. Poetry. Great. Poetry. Run. Yeah, so most junior tasks done by most senior engineers, so that you don't get things like linters misconfigured slowing down your pipelines. So the important thing here is, because I set I hope you can see the Beam screen there. So now I think it's working. Because I set the timeout period, let's see, which is important for testing. It makes it more expensive, but saves you time. Because the keep warm seconds set to 10 minutes, that container won't spin down unless those 10 minutes have elapsed without activity. As you can see here, we have our response. I'm just going to share the screen properly so everyone can see that. Screen, window. As you can see here, we have our response. So it correctly, I'll pop the PDF in a second. You can see it pulled out the PO number, the invoice currency in euros, pulled out the invoice total, the invoice due date. And so what I'll do is I'll actually just grab this and pop it into Jason Pretty Fire Online, Jason Pretty Online. And we can just look at that side by side with the PDF. Ooh, make pretty. So what I'll do is I'll bring up the PDF as well and show my whole screen. And you can see here on the left, I'm just going to make this smaller, zoom out a little more. So you can see what was extracted here. So we got our result with a supplier name, Thompson and Sons. I always get confused in this one. Yeah, so we are supplier name, Thompson and Sons. And then we have the PO number, Legion 11862. We have the invoice currency correctly extracted, which is the euros. And particularly on this PDF, which is why we use the thinking variant, and this ad can go away. You can see that I actually got the correct invoice total after the discount, tax, and VAT was subtracted. So 734.33, 734.33. And then we have the invoice due date, which up here is 16th of October, 2016. So there we go, 2016. And nice little trick is in our actual schema. If you look at that here, there's actually this thing I found called format date time. I hope you can see that for the invoice due date. And this to make sure it's the timestamp is RFC 3339 compliant.
Nice.
So you can pass this into your front end and like just parse that and just really have a really nice user experience. And then, yeah, you can look at other things like invoice number was sort of found correctly there. And State Bank of California. Let's grab, there we go. So State Bank, California. Let's see if we can find it. It's always fun to play the game of like find the thing on the invoice. Yeah, there it is. And this is why customers pay for this, because they usually have teams of 4 to 5 people, especially in accounts payable, who will try and match all these things to their CRM or ERP by hand, and literally just to make sure that everything matches up, just to save it into the ERP. So this whole process of the vLLM looking at that, extracting information, and then sort of comparing it against what's already in the CRM saves, on average for our customers, in one case, 60 hours a month just in that role, let alone the other 3, 4, 5 agents that they're bringing on. And in total, that translates to $200,000 a year, which for them is close to like 1% of their total revenue. So yeah, and then I think invoice number is probably on here somewhere. They picked it up, but yeah. So there we go. That's how we use Beam and why it's awesome. It just works, and I don't even think about spinning it down. It'll just spin it down when the time elapses.
This is crazy. It's crazy that you're able to save this company that much time. Like, what happens after this? What now you have this API that is able to take any PDF and give you structured JSON. But what happens next? Is it like just more accurate JSON? I mean, this worked pretty well. So what's on your roadmap for the next couple months?
So we want to add stuff like bounding boxes so that if you hover on the bounding box, I can just show you our staging environment. People can take a look at that and how we've sort of presented that data. I'll look it up in background. So we want to, our next roadmap is like bounding boxes so that companies can see, okay, we extracted this data from this particular place. And this is how, so here's like an example. Here's what our dashboard looks like. It make more sense to talk with that in mind. Can you see that there? So this is what our dashboard looks like for companies. And in their case, they can, we want to add bounding boxes so that they can see, okay, if I hover over this, you can see where I found it on the PDF. This is one of our older models, which is why you see, this invoice total, which is why we moved to the thinking model. We've already implemented stuff like scheduling so that customers can come in and schedule this stuff to happen on a given time. And we use a workflow engine that we've sort of customized to handle that. And then a really big thing on our roadmap is we're actually adding more workspaces. So we built a platform for builders to come and host agents and just scale them on our platform and serve businesses on their behalf. So as a builder, your workspace or agent would appear here for the customer. They can come in here and buy it, kind of like an Amazon product, and hire it into their business. and then the business can automatically sort of come in here and like add tools and integrations. So on the roadmap is basically we're going to open up this API soon in September for builders to come use that, and then we're going to add a bunch of awesome things like fine-tuning pipelines. So we're going to fine-tune an LLM for each customer as they use your agent, we automatically make that more accurate on their data specifically. So it's just a really magical experience, and then keeps the customer coming back to your products.
Right. So you could have an entire set of agents that automate the enterprise back office, all running on Solitude.
Yeah, that's the exact case. So underneath all this is a lot of infrastructure. So we use Beam, and we also orchestrate a few things in Google Cloud and a workflow engine. And this lets the agents execute reliable workflows, choose tools, and we also automatically handle the security and secret rotation, that kind of thing, on behalf of our builders, so that you build an agent and you create these workflows. You don't have to worry about connecting to the customer's Outlook. And on top of all that, we're going to layer MCP for each agent, for each workflow. And so the vision is for companies to be able to come here, hire your agents that you've built or that our service have built, and we'll automatically do all the pipeline and all the communication and infrastructure under that to make sure they can all communicate with you as a business over Slack, over Teams, and they'll share information with each other here. So we've also added support, and we also add activity audit trails. So for builders, we just took away all the really annoying parts of shipping an agent product, which is connected to other agents and integrations, and just let you build the agents so that businesses can just come in here. They have all the stuff out the box, audit trails, team management, all that stuff. And you get to just focus on building an agent, and we're rolling out some really awesome stuff around that.
Amazing. And if people want to get access to this, how do they sign up?
Sure. I mean, you can go to our website if you're a builder, and click the book a call button. Let me see if I can just jump on that right here. We're soon launching, so either book a demo and just say, hey, I'm actually a builder. I'd like to learn more, or just email us directly down at founders. It should be on the website, but founders@solitude.ai, and we'll definitely get back to you. We're actually thinking of open sourcing what you saw today, which was this accounts payable agent. So we're going to open source some of the code you saw today, and some of the infrastructure and how it calls our infrastructure. So if you're interested in taking an accounts payable agent to market, maybe not, so we're in logistics, but if you want to do it for like some pro tips, warehousing, they really need this, or 3PL or cargo, or any sort of document heavy industry. I think media and entertainment is also great. And you want to use this and host it on our platform and just let us handle all the annoying bits of distribution, then we're going to be making that open source soon. You can find us at founders@solitude.ai.
Amazing. This was super cool. Like, we looked at the code. It's crazy seeing the code that's getting you these enterprise contracts, because when it's open source, people could use that. But before then, like, they could just watch this. There'll be a recording of it. So it means a lot that you shared this.
Anytime. That's really what we're here to do. Like, I really want to help educate people. I hope one of the main takeaways is, first of all, Beam's awesome. Use infrastructure. I'll shout it from the top of my lungs. Number two, structured generation is really the way to go for building production like great applications. And then number three, let me think of a really good number three. Number three, it's not really about, as you saw today, like the amount of code to actually get something reproductive and useful is pretty short. A lot of what will be the future going forward is about the UX and the experience that we can provide users and these new form factors of interacting with agents. We started out with chat, which is cool, but to actually make it productive and really solve urgent problems for businesses, the important thing is to begin to develop or use, for instance, you might use Solitude's pre-built UI dashboards and stuff to create these form factors to make it easy for users to navigate. And that's where the future is going. It's a lot of the code would be like taking stuff like that, like your agent, and wrapping in a form factor that's easily usable, easy accessible, and can be like scaled up to an entire business.
Incredible. I'm excited to watch the journey. I obviously get front row seat to this.
Yeah.
And yeah, I hope other people watching this have gotten a preview of what you guys do and how they could also use structured generation to transform the enterprise back office.
Great way of putting it, actually, better than me.
Yeah, we try.
Thank you so much, Eli. Really appreciate to be on here and getting to talk about this. And yeah, best of luck. I'm gonna keep using your infrastructure. I can't wait to try the new GPU checkpointing feature. We haven't got around to it yet, but I think that's we've had customers who have said that, like, look, let me just give you $400 extra if you can spin the GPU up faster. We were trying to come up with ways to do that. You guys released, GPU checkpointing, and I was like, hey, turns out we can do it.
Yeah, let's do it. Next week, we'll live stream you guys using GPU checkpoint restore.
Awesome, man. Awesome.
All right, well, this was great. I'll talk to you on Slack.
Thanks, Eli. All right, have a good one. So
that's the playbook. Give a PDF, get JSON out. Now, the coolest part about this video is that this is the exact code Adrian used to get a contract with a $1 billion company. So if you wanted to build an AI app but haven't started yet, I hope this video motivated you to get something going. That's all for today. We'll see you next time.